I'll start. Just wanted to make sure, okay, that I don't go. Okay, 6:15. So this is the time. Is it switch on? Yeah. Okay. Great. Yeah. So thank you everybody for coming to CJUG tonight and our monthly meetup in July. It's always more challenging because everybody's on vacation or the weather is very nice today. Finally, yeah, we have some beautiful weather without storm. So thank you. Thanks for coming. And we have James Carman from Calibrity, the company I just recently joined as well. So James is the CTO of the company. He's going to be talking about Project Loom and virtual threads. Okay, but first of all, just want to let you know we're going to run the two JetBrains licenses for raffling. So you get the free license for a year, and it's donated by JetBrains. So if you want to scan the QR code or click on the bit.ly link or copy that, please do. We'll just take your email address and your name so that we will be mailing you the certificates. So. Okay, good. Yeah, I think one guy is taking a picture. Good. Okay. Okay, just some housekeeping. We have our Chicago Tech Slack if you haven't already joined and would like to be in connection with other technologists, enthusiasts in the area. And that's not just for Java people, but everybody too, within Chicago and outside and beyond too. And then we also have our Java off heap from Freddie Gemay, the previous leader of CJUG. He's still doing the off heap, and then with Bob Pollin and Josh Juno and Michael Manella. So check them out. And then, of course, if you haven't joined our meetup.com, that's our link. You can find us on Chicago JUG. So. And if you are not following us already on X or Twitter, the former Twitter, this is our handle at CJUG. And then our Discord, yeah, we've been running this or having this for a while too, if you haven't already joined us. And also for tonight, we usually create a room there if you want to have further conversations with everybody, with James, if you want to join Discord. Yeah, it'd be fun. Just have conversations there too. So, and I'll be sharing this slide deck with you too, just in case you like to have it. And then some community info. JetBrains is our community partner, so they've been donating these 2 licenses per month to us, so enabling us to run the raffle. And then there's also this devitjobs.us. They have jobs all over the world too, so it's a global community of job hunting kind of place. And then also there's a huge conference called We Are Developers that's based in Europe and in Germany specifically. They are running their World Congress this week, and we are their community partner too. So. And then another exciting conference, it will be by the legendary living legend, Venkat Subramaniam. And he'll be doing this in September, late September to October, so September 30th to October 3rd. And he's sharing this QR code to kind of offer all JUG members, like I think $50 off, something like that. Yeah, nice. Discount. So if you want to consider going, it's in Denver, Colorado, where he lives. So, and you can talk with me too further if you need more information too, and I can connect you with Venkat if you need to. Yeah. So. Okay, some upcoming events. We're still planning our August and September meetups, although we're talking about a lightning talk session, so that will give chances for you if you like to present a short topic or a short, 5-minute talk kind of thing. So please stay tuned for that. And then October, Venkat will be coming here for Go to Chicago, that conference that's been popular in Chicago. And Venkat will be here, and then he is offering to do a talk for us too in October. So please stay tuned for that. And of course, then Go to Chicago is back in town in October. That's October, I think, 21st, 22nd, 23rd. If you go to the website, you'll be able to find the information. And looks like we should be able to get some discount code from that too. So. And then other confirmed speakers, we are still trying to schedule Alina Urenko from Oracle. She's the advocate for GraalVM primarily, and then Josie Pamal from Oracle too. So we're trying to schedule them in at some point, most likely just doing virtual because they're based in Europe, not traveling at the moment. And then we're still talking about having some sort of unmeetup or unconference style type of meetup too. So let me know if you're interested, have any ideas for that or helping us to run it too. So we may do that in the near future. And then if you're interested in speaking at CJUG, please send your email with your proposals to present@cjug.org. And for job seekers and recruiters, please join our CJUG group on LinkedIn if you haven't already done so. And for today too, if you have any stories you want to share, like for example, you're looking for jobs, or maybe you're looking for collaborators to work on some projects, cool projects and idea. And also if you're hiring someone, you are welcome to share your story. So would anyone like to share anything right now? I know we're a small group tonight. No, but no pressure. But we'll have social hour afterwards too, so you can talk about it then too. So, all right. Now, for today's sponsor, thank you to Scalability, and it's a Cincinnati-based consulting firm. Very not your typical consultancy. It's like we're made up of developers, very developer-centric. So that's why I joined it. So yeah, so that makes a big difference. So great place. So that's all I can say. And then past sponsor, I still want to thank JFrog for having sponsored us for the past 3 years. And then we're expecting another company too, so that should happen to be sponsoring us. And then we also want to point out too, if you want other JUG communities, activities, some of them are still doing live streams or having hybrid thing that you can watch online. And we're good friends too with the Atlanta JUG, the Boston Java Users ACM chapter in New England, and then Garden State JUG in New Jersey, Kansas City JUG in Missouri, New York JavaSig, the oldest Java users group in the US, in New York City, and Pittsburgh JUG. So you can check them out too. They have events too that are quite consistent, like once a month thing. And there are others too. Now our speaker today is James Carman. He's the CTO at Scalability. And Scalability is a consultancy, as I mentioned, and is ranked 3,660th place in Inc. 5,000. So that's pretty good in 2023. Okay. Yep. And then James is a seasoned technology leader, a consultant, and Java developer for over 2 decades, and a pivotal member of the Cincinnati tech community. And you are a significant contributor to the ASF, Apache Software Foundation, multiple projects, committer, PMC on Apache Camel, Apache Commons, and others too, right? Yeah. Outside of work, James is deeply committed to his community and family. He's a father of 3 beautiful daughters, ladies, and a volleyball dad. Yes.
Absolutely, yes.
He's also an active member of the Seven Hills Church in the greater Cincinnati area. So with that, the stage is all yours, and thank you.
Thank
and really
you.
welcome
that was
having
great.
you here. Thank you.
Thank you.
Okay.
Thank you.
Okay, I'll move out of your way.
I'll hook up the.
Yeah.
Do we need microphone? There is a speaker, but am I speaking loud enough everybody can hear, right? I don't need to mic up or anything.
Yep.
Good.
It's good.
All right. Usually I don't have to. All right. Did you guys do any of those remote JUG meetups during COVID? Did anybody do any of those?
Yeah. Yeah, we
I
did.
joined London one time. I thought that was kind of cool.
Yeah.
Be able to join across the pond. So that was a lot of fun.
Yeah.
COVID brought us all a little closer together in some ways. So that was the bright side, right? All right. We're going to talk about Java's virtual threads. It's a new feature-ish. It's been around for a little bit, but not really well known. So thought I'd share a little bit about that. Again, thank you for having me here to share with you. She already covered everything. That is my face really big, in case you needed that. That's what that is. I've been working with Java since it was Java 1.0. We do have a slide later that shows the year of that, so you can do your math there if you'd like. She said I'm a member of CinJug. I was the director of CinJug for a long time, but I've been a member and actively involved for many, many years. Apache Software Foundation, husband, father, CTO. She covered all this stuff. It's pretty cool. I wish if we could make the microphone like bigger and it'd be like Iron Man. You know what I mean? Like that would be pretty cool. I think I'd like that a lot. Yeah. She did mention volleyball. I'm surprised you all don't know of me from the volleyball world. I'm kind of a big deal. I was the head coach for the 5th grade volleyball girls team at Villa Madonna Academy, a small Catholic school in northern Kentucky. Graduating class of about 40 people. But yeah, I was the head coach there for a couple years straight running. We won 2 or 3 games in the seasons I was there, but we fought hard. I'm surprised you hadn't heard about us. It's a very Cinderella story, but I'm kind of a big deal. And
Well, I didn't want to be one of those super fan weirdos, so
I appreciate that. I mean, we sign things after if you'd like. Thank you very much. I appreciate that. All right. What are virtual threads? This comes from the JEP 444. This is the one that implemented virtual threads finally in Java 21 last September, I guess it is. But you all can read this. I don't need to read this to you, but lightweight, dramatically reduced. This comes straight from that.
Okay.
So this tells you what they all are all about. I think that's pretty much self-explanatory. So that's all I have. So thank you for coming. No, I'm kidding. I'll explain it a little bit more. But they're lightweight. You can dramatically reduce the effort of writing, maintaining, observing, high throughput. Remember that word throughput, right? A lot of people get confused on that. They think that it's for something different, but it is not. So what are the goals of virtual threads? Scalability is a big part of it, right? So we want to be able to enable server applications that are written in that thread per request style. Everybody familiar with that? Every time a request comes in, we spin up a thread or use one from a pool. That style, we want to be able to scale that with near optimal hardware utilization, right? To be able to use those CPUs more efficiently and more effectively, and instead of letting them sit there idle. Enable existing code that is using threading APIs to continue to work. We want the compatibility. Troubleshooting is also big. Observability, troubleshooting. We don't want any craziness going on with having to, jump through a bunch of hoops to try to figure out what's going on with our code. So that's a huge aspect of this endeavor. What it's not. They do not want to replace and under the covers automatically upgrade to everybody using virtual threads. That is not a goal of the virtual threads. They're not trying to change the basic concurrency model of Java. We have had regular, Java lang thread, I guess it is, since 1.0. Since its inception, it's always been there. The basic concurrency model of Java is not changing. That is remaining the same. They do not want to change that. It's also not a goal to change the data parallelization, right? So if we're going to process data in parallel, continue using the streams API for that. That's still the way we do that. Don't change that. That's still the de facto standard way to do that. Another big thing, as I said before, we talked about throughput. I put the turbocharger here, right? So this is a turbo. This is not going to make your computer faster miraculously. These aren't faster threads, right? They're not going to just somehow turn your MacBook into like a Cray or something, right? That's not the idea. The idea is for more throughput, is to utilize the threads more thoroughly, more efficiently, to get the CPU utilization up so that those threads are not sitting idle. Okay? Any questions? I was very proud of this. I worked very hard on this diagram. I didn't steal this from anyone. I stole the verbiage, but I didn't steal the diagram. Showing you this idea of these virtual threads have actually been around for a long time. The idea of them have been around for a long time. They called them user mode threads, or they're still called user mode threads. But when Java first came out, way back here, 1.0, 1.1, told you to do the math. 1996 is when Java 1.0, that's where I started. They were called green threads, right? And the way they did it back then was you had one operating system thread. And all of your threads inside the JVM, many of them used one operating system thread, and they would share it. Sometimes not so nicely with one another. They would block and hog the CPU, and you wouldn't be able to get any processing done. So that didn't work out so well. Over time, by 98, and when 1.2 came out, you can see this yellow. This is the era of native or operating system threads. Right, then we had that one-to-one model. Every time you spin up a thread in Java, that corresponds to an actual operating system or a native thread in the operating system. And it's basically a thin wrapper around that. So that's this era, right? All the way from 1998 till about halfway through 2022 when Java 19 came out. Virtual threads came out in a preview release, right? In 19 and 21, 19, 20, 21, or 19 and 20, sorry. It was preview, and in 21, it was finally released fully. So it's just part of the language. You don't have to do the enable preview stuff. When you run your programs, you can actually use virtual threads. This model is M to N. There are M virtual threads in the virtual machine, corresponding to N operating system threads. Ideally, M is much, 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 much greater than N, right? You want to have a lot of threads, virtual threads, to very few operating system threads. Okay? Any questions? And feel free anytime, just pipe out questions. This, wow, that looks big on there. This is my mental model, how I kind of think about it. And I made these things really big on purpose because of the lightweight nature of virtual threads. You can see I try to make these things as skinny as possible. This is why I want to draw over here, because I like to point, and then I'd have to run over there and point on that screen as well. So I'm a pointer. They're very skinny. I couldn't make them any skinnier effectively in Lucidchart, so this is what you got. But it's actually more dramatic than this, if you can imagine, right? These should be like really fat. But you see these virtual threads are basically catching a ride on the platform threads. These are what now we call them platform threads. Now that we have virtual threads to distinguish between the two, they're now called platform threads. The normal old threads that we always had, we call those platform threads as opposed to virtual threads. Now, when the virtual threads spin up and they're doing work, they have to catch a ride. You can see this one starts and it hops on this platform thread. When they are added to the platform thread in order to run, that platform thread becomes what we know as a carrier thread. That's what we call them. Doesn't mean it's any different than a platform thread. It's just playing the role of a carrier of virtual threads. So it hops on there and does some stuff, and then it gets to a point where it can't do stuff, it blocks, and it is then, we call that unmounting, mounting and unmounting. So it gets mounted onto the carrier thread, and then it's unmounted off of the carrier thread. We'll go into a little more detail about that in a few slides, but that's the idea. And you can see that there's no affinity here. This thread, yes, it hopped down here, then it went up there, then it came back down here. It can bounce back and forth, right? On any carrier thread that's available. It can be executed on any carrier thread. Does that make sense? Okay. So how does this work? Well, it's kind of magic-y, honestly. It's not, but it seems magic-y. They use what's known as continuations. Anybody ever coded with continuations before, right? So it's kind of a weird paradigm, I guess, right? This is not something you really do. This is not runnable code. I was just using this for illustration purposes. The continuation class in the JDK is actually an internal. You can't see it, you can't use it, but this is kind of what it looks like. I just used an approximation. So you see this run method, it's kind of like a runnable, right? Like we would run a thread, right? It's going to print hello, and then it's going to yield itself back to the whatever. And then after that, it's going to print world. So the way this works, I created a new one here and I call run. All that's going to print is hello when I call run. And then run's going to be finished and I can go to this next line. So this is where it gets kind of funky. This continuation, that run method, when this is called, this yield is called, run actually returns. I don't execute that last line in the body of that function. This run actually returns. When I ask the continuation, are you done? Nope. I can call run again on the exact same object. What does it do? It continues right where it left off automatically. Continue, run, continue, yeah, run, yield, this little back and forth. You can have multiple of them in there. And it's like, the way I was thinking about it myself is like when you're reading a book, right? You're reading a book, and you get to the point where you need to go do other things like us dads have to do, go run dad's taxi to volleyball practice. You put a bookmark in your book, close it up, set it down. You come back to it later. You continue reading from where you left that bookmark. So you can think of these yield spots as kind of like putting bookmarks in the code, right? That's how I mentally think of it. And then those continuations, when you do this, it can continue where it left off after a yield. Any questions? I'm not going to go into how it does that. That gets into some really nasty stack gymnastics that they do in the JVM for this. And it's pretty wonky, but it's pretty cool. We can talk about it later, but yeah. So the way they implement these virtual threads, they have a virtual thread scheduler in the virtual machine, in the JVM now. These virtual threads are added to a queue, as you see up there. So the thing that runs them is these continuations. This scheduler, as we said, will put those things onto its kind of an internal queue. It's actually implemented as a fork join pool. Has anybody ever used a fork join pool? But internally, it's kind of a queuing mechanism, right? It queues up tasks. The threads that are members of the fork join pool are grabbing these things. So the carrier threads that are inside that fork join pool are pulling things off this queue in order to execute them. So as we said before, on the continuations, all you have to do is call run. So all this thing is doing, it has no idea what's going on inside the run method. This carrier thread grabs a continuation and says run. At some point during the execution of that, inside the continuation, it's going to yield itself, right? And that's where you do that park. There's a helper class in the JDK now called lock support that has this like park and unmark. There's all these different verbs: mount, unmount, park, unpark, freeze, thaw, like it's very confusing. So I apologize, but they do use these verbs in these scenarios. So I was trying to represent it as closely as I could to the actual terminology they use. But think of it as basically the continuation saying, I'm at a spot where I can't do anything right now. That's usually a blocking operation of some sort, right? And it's going to tell the scheduler, I'm stuck, or this is what I'm doing. So the scheduler then, its job is to translate that blocking or whatever reason that it needs to park it into a native operating system operation. So that could be setting a timer in the case of like a thread.sleep, a native IO, a non-blocking IO operation at the operating system level. It's going to hand it off to the operating system to go do that IO, but it's going to be sitting there listening for, when you're done, come let me know when this is finished. And then the operating system is kind of delegating that and offloading all of that behavior. And then it's going to set these little continuations that are waiting for those things off to the side. And it kind of knows, oh, I was waiting on that timer. I need to go wake this guy back up. I know this was the one who had a thread.sleep. When he gets the notification back from the operating system, his job as the scheduler, go back into this little pool of folks that are waiting, grab them, put them back on the queue. Now, again, the carrier thread doesn't need to know anything special. It doesn't matter how many times that thing spins through this queue. Every time it picks it up off the queue, run. Next one, run. Its job, it doesn't need to know, I have to go figure out where that bookmark is and resume the thread of execution at the exact right spot. The continuation handles that for it. So this thread can be really dumb. It just calls the run method on these continuations over and over and over. Okay? Any questions? Yes.
One question will be, how does the system stop the actual, I don't know, an intrinsic block or a native kernel block stopping the whole pipeline?
Fantastic questions. So the question is, how does the scheduler know when to, let me make sure I'm phrasing this right, keep me honest here. When there's like a native call or something that's intrinsic to the operating system going on inside the virtual thread. That's a problem. It can't, right? So that does, we talk about it later. So it's a concept called pinning. We do talk about that later, but it causes a real problem. If you're doing something native, if you're even using the synchronize keyword, as it turns out, inside your run method of your thread, that's a problem. It's going to cause an issue because they use native operating system mutexes in order to control those synchronized keywords. Okay. As you said, native code, external foreign code also causes the same problem. Fantastic question. Yes, sir.
How often the Java machine inserts the continuation?
Question is, is there any way to ascertain how often the JVM or is inserting these bookmarks? A good question. So this is an interesting thing. How they pulled this off, you should see the pull request for JEP 444 when they finally inserted this in there. Thousands and thousands of lines of code. Everywhere that an IO operation happened, you had to insert this little logic to say, I need to park myself. So it's basically doing that by hand the JDK code internally is doing it by hand. Thousands of spots in the code it had to do that. You can think of every time you did a sleep, every time you did IO operations, socket, IO, any of those sort of things, they injected those little calls. That's why there's that helper class, as I said, I think it's lock support. And then there's like park and unpark or mount and unmount. I don't know which verbs they use in that class, but there is a lock support class for that. So thousands of spots that we had to like clutter up the JDK and all that code in order to pull this off. But it's happening seamless to you. You don't have to do it yourself. Good question. Good observation. Anything else? I think if I missed anything, I think I got everything. Let me take a drink. Okay. Is this, there's been kind of a little bit of a struggle going on where people are kind of arguing whether this is preemptive or cooperative scheduling. Does anybody know the difference between the two? You want to know?
Yeah. Preemptive is where when the threads themselves are giving up control flow voluntarily. The cooperative, I don't know.
So it's the other way around. So preemptive is when, and I use this, and this is actually an AI generated image. I said, give me an image of two kids fighting over a toy. They did a pretty good job. No extra fingers, right? Ears are in the right spot, all the good things. Like, I thought it was a pretty good image. Nice light shit, you know, it's really good. They did a good job. So this is from ChatGPT. They generated that for me. Anyway, sorry, I got off track. I think of this as like preemptive versus cooperative is like two kids are fighting over a toy. Preemptive, as a parent, I come in and say, stop that, stop that, stop that. Give me that toy. Okay. Billy can play with the toy for 5 minutes, and then you can play with the toy for 5 minutes, right? Like that's me getting involved, taking the toy away and giving it to someone. In the case of a scheduler, that's taking control away from a thread, actively interrupting the thread and saying, nope, you're going away. You're not going to be on the CPU anymore. You're not allowed to do that. Cooperative would be the children themselves. Billy would say, you know what, why don't you play with the monkey for 5 minutes, and then I'll take a turn in 5 minutes, and I can play with the monkey for 5 minutes. Cooperatively deciding when to give control of the toy to each other, okay? So after explaining how all of this works, which one is it in the JDK? What do we think? They're arguing back and forth. The JEP authors would argue that it is preemptive. And I guess from the perspective of a Java developer, I guess it is. I don't have to tell anyone when I want to give up my virtual thread and let it yield and go off into that little pool off to the side. But somebody does. It's not like forcefully happening. There is an actual like yield call happening. The operating system isn't, and the JVM isn't reaching in and saying, no, stop. Every time I'm going to age myself. I think of like, stop what you're doing because I'm about to ruin. Never mind. The Humpty Dance. Sorry. Every time I think of that, I think of the Humpty Dance. But I'm a weird guy. What can I say? So what I think of it as, it's kind of both. I think of it as almost like delegated cooperative, right? I think the intent of the authors is you think of it as preemptive. You don't want to have to think about when is this going to block? When is this going to give up control and go back and allow other people to use that thread? You don't have to think about it. Ideally, in the future, maybe it can be a little more preemptive in the way it does things, and it can interrupt more and more things. Right now, it's only those specific spots in those atomic level operations, those low level operations that will yield and give the thread back. Does that make sense? So it's like delegated, cooperative, probably preemptive in the future. It's kind of how I think of it. Yes.
More points than that, or maybe when you get safe point or something like that.
It's wherever they decided to do it. So it has to be done manually. And most of those, the way they've explained it is blocking IO is the primary spot where they're looking for that. The sleep calls and locks. Anytime you're doing like a lock and unlock situation. The question was, is there an opportunity for it to be at a safe point where the JVM could kind of reach in and say, stop, I'm going to pause you myself. Right now, there isn't. They had to do that manually. That's why that pull request was ginormous, was because they had to go in and sprinkle those calls everywhere. So it was pretty gnarly. If you know anybody who works on the JDK, give them a high five. That was a heck of an effort. It was really cool, and it's going to pay off. I think this is a really neat paradigm for us. So all this complexity, all this craziness that we had to put into the virtual machine. Why? We already had. If the goal is to keep the keep the CPU busy more often, right? We already kind of had a paradigm for that, right? Reactive streams, reactive programming, futures, any of those like callbacky type mechanisms, those are designed specifically to do what this is doing. We already had that. That problem's already solved. So why would we go through all of the trouble to clutter the entire JDK code base with all of these little hooks and everything and complicate the threading model and all of this? Why? Has anybody ever written callback-based code? He's sighing over here. I think I'll take that as a yes, as a hand raise and a, yeah. It's not fun. Yeah, it's not fun. So if you've done anything in Node, you know what this looks like. You know, the callback hell of Node and JavaScript. It's notorious for that. There are libraries that make things look a little nicer and a little syntactic sugar, but your mind, you always have to be conscious of this asynchronousness, right? There's always going to be this async keyword sprinkled about on the method names and the function names and all of that. You always have to think about, well, this is going on somewhere else, and I have to be conscious of this, and I have to chain these things together and all of that. So this is what that style, that non-blocking style of coding looks like. I've said callback hell. That's what a lot of people call it. All these things are callbacks. When this is done off in another thread, then compose, then apply. And it's hard to envision in your mind what's going on. It's hard to debug. Each one of these little things can go on in a different thread, so it messes up the stack trace. So you don't know, like, okay, this was here, but that's not part of the same stack trace over here. And it's hard to correlate things together. It's much more complicated to code this way, as opposed to the blocking style. And I think this is, for me, this was the big aha moment, right? Like, I was reading about virtual threads. I don't get it. And then finally, these sort of illustrations really made it hit home for me. It's like, oh, you mean I can write all this kind of code and I don't have to do Project Reactor or RxJava, or I don't have to do, I mean, you still can do futures here and there, even with this type of code, but I can just write kind of normal code, the blocking IO, and it's okay. So you can think about this get body call. This is probably going and doing an HTTP call somewhere. When it gets to the point where it has sent the request off to the other HTTP server, the IO classes inside the JDK are saying, stop, unmount me from my carrier thread. I can go off and sit to the side for a little while until this answer comes back. It does it for me. I don't have to do it, and it automatically remounts it, and it knows, okay, when the answer got back, resume processing, boom, here, and now I can go do this. So it's taking me on and off the thread automatically. I don't have to be conscious of it. My stack trace looks really nice because it just follows a normal progression of code, just like it always would, right? You know where things are. Does that make sense, everybody? It took me a while to like that aha moment for me, honestly. I don't think I'm that smart. I don't get to code anymore that much. Maybe that's my problem. I need to code more. But that blew me away, and I was like, okay, this is pretty cool. This is like the sleeper feature that I don't think enough people know about yet. This aspect of being able to write just regular code and be able to maximize my CPU usage. I can use this code, and I don't have to worry about parking my thread and blocking the operating system thread. It will stay alive and keep processing and keep churning along. And I can get more throughput in my, REST services for free. You think about it, if I can upgrade all my services to use this paradigm, and I've always been writing this way, I get an instant performance increase. And we see at the end what that looks like. Compute goes down. I think it's going to be a big thing for us. Combine that with Graal VM that you talked about earlier. Man, now we're talking. All right, let's talk a little bit about syntax stuff and how do we do this. So this is how do we create virtual threads? They have these new static methods on the thread class. So you can create, this is called a builder. It returns a thread.builder from this of virtual. And then you can call start and give it a runnable, right? So this returns you an already started thread here. You can join just like you do any other thread and wait for it to finish processing. Of course, I had to put throws exception because this join throws interrupted exception, yada, 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 right? You still have all of that stuff. That API did not change. Any questions? There's a corresponding of platform. So if you want to create a platform thread, you can use the same sort of functionality to create platform threads. Of course, the old new thread stuff is still there because they couldn't ruin the backward compatibility, but if you want to kind of be able to have frameworks that switch back and forth, you can use this one or the other, thread of virtual or thread of platform. Okay. Any questions? Okay. Pretty straightforward. Thread Factory. This one's been around a while. You guys use Thread Factory? You see it? It's in some of the APIs. It's sprinkled in here and there. It was kind of, as I was looking at it, I was like, I've been doing this a long time. I don't know when things got to the language or not. It's been around for since 8 or something, Java. It's been around a while. I was surprised. So you can get a thread factory. So you do the same thing, a thread of virtual dot factory and turn it into a thread factory. And you can feed that thread factory into all of the existing things that use thread factory. There's a lot of places in the JDK that do. Thing with thread factory is it doesn't start. It doesn't create them. My head's in the way. It's just saying hello world. It doesn't create them in a started fashion. So you have to call start on the thread that's returned. And again, you can join. There's customizations where you can, do things with how do I name the threads when they're created from the factory? There's other customizations, but this is the gist of how you do it. Matter of fact, it comes from a gist on GitHub. Thank you. Somebody laughed at that. Took me 2 days to come up with that joke. No, I'm kidding. I just did it just now. All right. This is the third major way of creating virtual threads. So this was kind of the best backwards compatible way they did it is by using executor service. How do people say that? I say executor service. Some people say executor service, kind of sound like you're executor of a will. I say executor. Executor? You're like, no, shut up and just keep talking. Anyway, they extended this. There's a new one called new virtual thread per task executor. There is a thread per task executor, which you can give a thread factory, and it will use that factory to create one. So you can do that and pass a virtual thread factory. But there's a fancy way to do it by just using this very long name. But what this does is every time you submit a task to this executor service, it creates a new virtual thread and just spins it out, right? But that's okay. We want that. This new style, you can spin these things up like nothing, like they're like candy, right? They're very, very lightweight. Here, I'm spinning off 100 of them. No problem. 100 platform threads. Anybody do that a lot at any given time? Just spin off 100 of them for every request that comes into your web service. Spin off 100, spin off 100. Does you guys ever do that? Doesn't last very long. Doesn't work very well, especially for long-lived threads. So executor service, submit them, and then I print that. Pop quiz. What happens here, though? When does this print? You're answering everything. Anybody else? And you might know the answer to this. It's kind of a trick question. So remember, these are all executor service. These are asynchronous threads. This is a virtual thread that's going off on the side and doing this system out print line. I can spin those up very, very quickly. Now, that doesn't mean they execute that quickly. And then I'm done with that for loop and I get out here and I do system out print line. Does this print interleaved with some of these. Maybe I print about 30 of the hello worlds and then I see finished and then I see 70 more hello worlds. Normally what would happen? This is kind of a cool new feature. This one caught me by surprise as I was digging through the documentation, and like it was like, oh, wait a minute, that's actually kind of neat. Notice I'm using try with resources here. Is everybody familiar with that pattern? Anything you put in that between those parentheses, if it has to be auto closable. The close method of the executor service waits until every one of the things that it was submitted to it finishes. So it's going to go off and print off 100 hello worlds and then drop out of this try with resources block and then do the system out print line. So this is a really cool way of doing like fan outs. So if I need to call, like if I'm in a BFF, there's other ways to do it too, but if I'm implementing a backend for front end, anybody know the pattern, right? So when I have a user interface and I want a bunch of different data from a bunch of different web services, I don't make my user interface go call all those services. I create a BFF. It goes and calls all those other services, aggregates it together, and then hands back one response to me. So if I'm doing a BFF and I need to send out, 20 different requests or something like that to different web services, if it's 20, I might need to rethink what I'm doing. If it's 5, maybe, but you can fan that out. And so you can use this executor service, new virtual thread per task executor, fan those out, let them all go run, and drop out of your try with resources. And when this is done, all of those tasks are finished. I can rely on the information that I went and fetched. Does that make sense? Pretty cool new feature. Really like that. But there's a better way to do it. We'll look at it later, but I thought that was pretty cool. Any questions? Comments? Concerns? Jokes? Okay. So tips and tricks. So this is kind of a usage guide, more than tips and tricks, I guess. Usage guide for virtual threads. This is probably going to be the biggest thing that, especially for us old timers, to learn this new habit and to not think of threads as some scarce resource. Platform threads are, virtual threads are not. You can have millions of virtual threads and it's okay. The context switching is minimal. They do a lot of tricks. As I said, they do a lot of gymnastics with the stack frames and all of that. They even lazily copy stack frames around. So they only load them back out in when they need them. There's all kinds of tricks. So these things are super, super fast. You can have millions of them. You don't need to pool threads anymore for these type of threads. You can for other things. No pooling. One of the rules of thumb I saw in one bit of documentation said, if your application doesn't at any given time have 10,000 virtual threads running, you probably don't need them. You're not really writing an application that could really benefit from virtual threads. That's a big number. Does anybody run systems with 10,000 platform threads today? Do you? Yeah. Yeah. What kind of machine you have to run that on? Pretty beefy machine. Yeah. Yeah. 100 cores. My goodness. I'd like to see that. That's cool. So that's like a feat of amazement but now I don't have to worry about it. So this is a new habit, a new way to think about things. And these virtual threads, don't think of them as threads so much as really they're just tasks. I need something to happen and I don't want to have it happen in this thread. I wanted to go off and go do something. So think of them more as tasks. That helps to kind of reframe your brain around the lightweightedness of these things. But this shift in paradigm can actually bring with it a different set of problems that we might have. As I said before, this structured concurrency, this is a preview feature. We were talking about that executor service thing. This is kind of a extra. This is the new thing. This is the thing that's in preview, structured task scope, right? This one, there's a couple different flavors built in. There's shut down on failure. What that means is go do a bunch of things that I need, and if any of them fails, fail. If any of them. So it's like a BFF, like this one is. This is kind of a BFF example. Any one of, if I can't go get the list of accounts, fail. If I can't get the customer, fail, right? That's the idea of them. There's another one that's kind of like, give me an answer from just any of these things. So you think of like, just give me the thing that responds with the first answer. It's good enough for me. I'll take that. And then you can shut down all the rest of them. It doesn't matter. It's called shut down on success, which sounds weird, but that's what it's called. So shut down on failure. So what you do, and again, try with resources. You can fork processes to go get things, and you can store these off. And then after you're done spawning off your threads to go get things or go do things, you can join on the scope itself, and you can tell it what to do. Throw this exception if anything failed. Right? Now, once you get past this, just like thread join, you know you're good. All of those things are fine. Those suppliers are now good to go. You can call and go get things from them. They're already back, and we know they're okay. Nobody failed. So I can return my view model customer.get and accounts.get. The cool thing about this, in my opinion, is this. Well, how would we have done this in the past? What would that word be in the past? And today as well. Future? Did you say future? Yeah. This word would not be supplier. It would be future, right? Typically, when we're doing asynchronous processing, we'd get back a future all the time. So this, the actual subtype of this, there's like scoped task or something like that. I don't know what it's, but it's something, but it implements supplier. This supplier is a really simple API. It's just get. There are no exceptions on supplier. It returns the thing you're looking for. You just call get. So it kind of erases the asynchronous, that's not even a word, asynchronous, never mind. The asynchronous part of this is kind of erased from your mind, right? You don't really have to think about it as much anymore. Until, of course, you get to this, and then you have to do that stuff. So we still have the interrupt, but that's a new feature. It's coming out. It's still preview in 23, I believe, scheduled for preview. But this one's pretty cool. This is a nice way to clean up some of those like BFF type patterns, fan out patterns, to make them a little easier to code. So this was I injected that slide, forgot about it. So my segue into the next slide didn't work very well. This is the problem I was talking about 5 minutes ago. When you spawn off millions and millions of these virtual threads, that causes another problem. So think about a situation where, in this one, it's a credit score service downstream. I've paid a partner to provide me credit scores for people. If I give them an SSN, they will give me back a credit score, right? Pay for a certain level of service. I just lost the mic. I pay for a certain level of service. They'll let me call, I don't know, 20 concurrent requests. If I'm spawning these things off with virtual threads, and there are millions and millions of them, like Guru would say, right? I'm going to overwhelm that service. I'm going to go way past my SLA. So this is introducing a really gnarly problem for us that we have to now be careful. In the old world, if I'm in Tomcat and I'm processing requests with my thread per request, I have 200 threads. So that kind of throttles me. It's just built in. You get built-in throttling because you're limited to the number of operating system threads that you have access to. We won't have that anymore. So this is going to cause us to, we have to think a little bit here. One approach to limiting your concurrency for downstream services is to use a semaphore. Has anybody ever used semaphores before? Semaphore is an interesting concurrency data structure where you basically instantiate it with a number of, they call them permits, right? So let's say this one, if our SLA on this service, this credit score service, is you can't send any more than 10 concurrent requests, well, I would create a semaphore that has 10 permits in it. And every time I want to make a call to that service, I would go to the semaphore and say, give me a permit. And now while I have a hold of that permit, nobody else can have it, right? Nobody else can grab a hold of that. I hold on to that. I make my call, go do the credit score thing and all that. And then I release that permit and I give it back to the semaphore. Now it's available for somebody else. It's kind of like a pool, but it just uses a counter, right? So you're just kind of, it's a pool of permits. You can think of it that way. So that is a way that we can start to not overwhelm downstream services and that we are consuming, because this is absolutely going to bite us when you introduce virtual threads. If you start using them just like crazy, yeah, you're going to have this problem with downstream services. Does that make sense? Semaphores are kind of a cool data structure. I'm glad that we're actually getting to use some of these cool things. Nobody really used them very much. We didn't have this problem. So I'm kind of excited about this one. I had to do a semaphore-based approach for, I think it was a credit card processing app I was writing. The mainframe only allowed so many concurrent requests going back and forth with the mainframe. So we had to basically put semaphores in front of it to not get ourselves in trouble with the mainframe guys. And trust me, you don't want to make mainframe guys upset. But look at them shaking their head. They've done it. They've done it. They're a special breed. You do not want to upset the mainframe folks. Okay. Avoid expensive thread locals. So in the past, we would have thread local variables for things that were expensive to instantiate, right? Heavyweight type of things. I've seen that one of the examples is a simple date format. They are not, and that's not really an expensive object, but the example is you attach a simple date format to every thread via a thread local, and then you can use it because it's not thread safe. And you don't want to synchronize around every call to the thing to let it format dates for you. There are new classes for that. We wouldn't do that these days. There are new thread safe classes for that. But in the past, we had to do that with simple date format. We had to either pool them or attach them as thread locals. Now, if it's an expensive object to instantiate, which is the reason I'm using a thread local, it's expensive. And now I'm spinning up millions of thread locals. It kind of defeats the purpose of using thread locals to hold those expensive objects, right? So we can't do that anymore. As a matter of fact, one of the byproducts of using reactive frameworks with virtual threads, some of them do hold very important synchronization and bookkeeping stuff about the streams that are going on as thread locals. And you can really mess up things and cause a big bloat to your JVM if you use virtual threads with those, because they make copies of all these thread locals everywhere and all these virtual threads. Before, you would have, if you have a pool of threads and you attach a thread local to one of the threads that's in the pool, it just stays there with the thread, right? Forever. It's fine. I instantiated it. It stays with the thread forever. If the thread dies, it goes away. We spin up a new one. Maybe we attach a new thread local to it. But we don't do that anymore. We have millions and millions and millions of these things. So you have to be very careful when attaching expensive objects to thread locals. Quick and dirty stuff like, here's the current account username or account ID and letting that propagate through. Sure, not a big deal. But expensive stuff can be really nasty. There's another new feature of the JDK. This is a preview as well. I think they're scheduled to the other thing, this thing, and scoped values is scheduled to go out together. They kind of work hand in hand, as you can see here. So this is basically the usage of it. Typically, is you'll create a scoped value as a static final variable. It's not always, you don't always have to do it that way, right? But I create an instance of one. So this is in lieu of thread local variables. Then I do scope value run where, and I'm basically saying run it where this scoped value has this value. Anything that goes on inside this runnable, all of the things here will see that value if they call, where is it? Account number.get on there's a get on that thing. So if they call this inside that scope, they will get 1, 2, 3, 4, 5, blah, 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 right? So this, you can see also anything I do inside a structured task scope will automatically copy, and it's aware of these scoped values. This is forking off into another virtual thread, right? So we're doing that spawning of virtual threads. When you use these two in cahoots with one another, anything you spawn from a structured task scope will automatically inherit those things. One of the benefits of doing it this way is there is no account number.set on the scoped value class. You can't just arbitrarily set that, but with a thread local, anyone down in the stack anywhere can reset that thread local. It's like a global variable, right? With this, the only way you can set it is by using these helper functions here, right? This run where, that's the only person who's allowed to make changes and bind things to those scoped values. So everything that happens down in the guts of that will get the right value. And then when it returns, it's gone. It's unbound from that. So it helps you limit the way you would do, like not having to use thread local variables for this. And you definitely, for one-way communication where you don't want to have to, so what I did here, you can see I didn't have to pass the account number as a parameter into all these things. I just had a no arg method. That's kind of a contrived example. I probably wouldn't do it that way. I probably would pass an account number, but you can see where a lot of logging frameworks like to use, so you can kind of attach knowledge to the thread. So when you do logging, you have the right correlation ID, right? Those things when you're wanting to do tracing and all of that stuff. So you might bind like the correlation ID to the thread as you're going down. So that's what this is for. It's to replace our thread locals and help us not do that anymore. Does that make sense? Again, preview, you have to enable preview right now in order to use it, but it is there. Okay. You mentioned earlier, when we use anything that's synchronized, when we use things that call native methods or foreign functions or foreign APIs, it's going to cause a problem. The thread cannot. It may try to say, hey, I'm ready to be unbound, but if there is a live one of those things going on and it's kind of using up operating system level native code, it cannot unbind. It cannot unmount from that carrier thread. It's basically pinned. That's why they call it that. It is pinned now to that that carrier thread. It cannot unmount. So if it is truly blocking, that virtual thread can now, or that carrier thread can no longer do any other things right now. Now, doesn't mean that the program is wrong. You just want to avoid really, really prolonged pinning, right? There's, and I can show you what we can run a little code and play around for a little bit if you want. There's a system property that tells it to print out anytime a pinned virtual thread happens. It gives you the stack trace and shows the exact place where you're running into the problem on the stack trace. Like, hey, look here, dummy, this is what's causing your error. It's just an info level thing. It's not an exception. It's not going to run optimally. You're not taking advantage of virtual threads optimally. There's even an example. You might see it if you just start playing around with virtual threads. If you're using MySQL, I don't know why you would. I'm just kidding. If you're using MySQL, the driver, anything before 9.0.0 is not built for virtual threads. They use synchronized blocks all over the driver. You will not see the performance benefits of turning on virtual threads if you're using MySQL as your data store. It will inhibit you. If you turn on that pinning logging, it'll light up like a Christmas tree. It's pinned all over the place, right? So you want to avoid that. One way to do that, now you can't really do much with the native calls and the foreign functions and all that stuff, but when it comes to synchronized keywords, there are other approaches to that. Use locks, use a reentrant lock, right? That's what some of the JDK classes had to do that. They had to rip out synchronization out of a lot of stuff and replace it with reentrant lock. That was part of that big, actually, I think that was actually another pull request that they cleaned up some of these things ahead of time so that they could take advantage of virtual threads. Does that make sense? Yes, sir.
If file or socket.io introduces speed.
It does not all of it. There are some, if they're taking advantage of native, there's certain native things that the file implementations do. The question was, do file.io and socket.io cause this? I think they were able to avoid most of that when they implemented it. And there's still talk of like, this isn't always necessarily going to be a problem. They might figure out how to do mutex locking at the synchronized keyword, the monitor level. do that differently. They've relied on operating system level mutexes in order to implement that in the JDK forever. That's just how they've done it. I think it was probably, and you can imagine it, if that was too much for the already huge PR, it must have been pretty gnarly for them to not rip all that stuff out. But they do anticipate that there will be less and less of these occurrences, that they'll be able to mitigate this and get around this problem more and more. Now, I don't know about the native stuff. That might be a little too gnarly, but good question. Any other questions? Okay. So Spring Boot, maybe Spring Booters. A lot of people are. How do you enable virtual threads? So it's a really tough process. You just set this property. Well, you have to be using JDK 21 and above, but you set this property. It will automatically transfer Tomcat's request handling to virtual threads instead of native threads. You don't get the 200 platform thread handling that you normally do. It's just virtual threads. This is all you have to do. And pretty straightforward. But does it work? I think it does. So I did a little test. My test was a simple web service where I introduced a thread.sleep of, I think it's 500 milliseconds into a web service. And I used Gatling. Anybody use Gatling for performance testing? No? Yeah. Oh, there's some. So it was big in the Scala folks. They liked it a lot. It was built on Scala. The internal guts is all written, and you're kind of using Akka inside the covers, but it allows you to, it's better than like JMeter at being able to push more and more load at a target web service. You can get a lot more out of Gatling than you can out of something like JMeter. Anyway, I use Gatling, and it spits out some fancy graphs. So this is on my Linux server at home. I didn't change anything about the code. The only thing I changed was that one property. I turned the property off for this. I run it just stock Spring Boot. It's very straightforward. The code's actually in the, I have a Git repo for you if you all want to download it and play with it yourself. The Gatling test is in there. You can run all of this on your own. There's even some parameters. On my Mac, there was like some settings. When I first ran this, both tests kind of blew up and started going wonky on me. There's a setting on Mac OS, like whenever you give up like it's a port number, right? So those ephemeral ports, whenever you take one of those and you're using it and you're done with it and you relinquish it, there's this delay of like 10 seconds built into the operating system by default, that it'll just hold on to that and not let anybody else use it for 10 seconds. Well, as this thing started ramping up and I was firing more and more requests, I was running out of ports. That was what was happening under the cover. So when I changed that, and there was another setting, I think I have it in the README, it made this a lot cleaner, but it still went a little wonky on me. This is with platform threads. As you can see, what I'm doing is I start off with 100 users per second, and I think I went up to like 1,000 in 5 minutes. That's what it was, something like that. I'd have to look at the code, but it's something along the line. But it's a 5-minute long test. So you can see this is the number of requests per second. It started going up and up and up. How many active users there were. The response time, you can see it was very happy, probably until it got to that 200 thread limit, which looks to be, about right. The 200 thread limit, it can usually do 2 requests per second because it's 500 milliseconds. 200 is probably about 400 requests per second or whatever responses. Then it started going nuts, crazy, starting to, the response time started going very crazy, unpredictable. Errors. This is the total number of error responses out of the whole thing. My little Pac-Man got a pretty big wide mouth on that one. Lots of errors you can see started to sprinkle in, right? There's a few little, maybe a little sprinkle here and there, but then it really started to go crazy here. So that's with platform threads. Quite different when we switch to virtual threads. And this literally, all I did was change that property in my application. That property just started the thing back up. No native compilation, no nothing, just changing it to virtual threads. No errors, very steady. And in fact, I think it could have gone more. One thing I noticed, and I was keeping an eye on top, this isn't scientific, I didn't have a profiler attached to it, but I was keeping an eye on top on my Linux box. With the platform threads, with the native operating system threads, I got to about 36, 38% CPU. And then it started, you know, going wonky on me, going a little crazy, right? With this, it just kept, the CPU kept gradually going up and up and up and up and up. I'm using more and more of that CPU because the threads are not going idle on me. I'm just using them and churning and actually doing processing. So it used over 90% of the CPU eventually before, you know, it was done feeding users at it. So I did not push it to where it fell over, but this is a pretty compelling example, in my opinion, right? So this versus that, much cleaner. So this is showing that we can get a lot more throughput, a lot more stable throughput from our services by just merely one property. And don't use MySQL. Just kidding. You can use MySQL. Now that they have the 9.0 driver out, you can use MySQL. Any questions? That's all I have. Any questions? Yes, whoever, just belt it out. Look at them. They're like, no, you go ahead. You go first.
So.
Well, there's some scenarios. So the question is, if we're, I lost my mic. I'm still on. If we're using Spring Boot, we're on Java 21, should we turn on virtual threads? For the most part, yes. But I would say if you're already doing web flux and you're doing reactive-based programming, you're probably not going to see a huge benefit. It's already kind of optimizing itself for that. I would see what, you know, if your code base has already kind of gone through that struggle of implementing everything in that callback style and that reactive style, you've already kind of bit the bullet, right? Turning on virtual threads can cause problems with reactive frameworks, as we talked about earlier with those thread local variables. So it could be hit or miss. So you could try it, run a performance test and see what happens. And you could turn it on for, maybe not turn it on for Spring Boot itself for Tomcat, because you're already kind of using Webflux, but that doesn't stop you from spinning up virtual threads while you're processing behind the scenes. You're not replacing Tomcat's internal guts, but you may go spin off and use virtual threads to go do the asynchronous things that you're doing outside of the Tomcat thread per request model. Good question.
Change the config, but not the code. But earlier you showed that some of the new methods to get virtual threads. So it's like existing code will continue to use platform threads. But that config control Tomcats?
Yes. Yeah, that's a good question. So I should have been more clear. That property, the Spring thread virtual enabled true, I think is what it is. When you turn that on, that basically tells Tomcat, or tells, it's actually Spring Boot reconfiguring Tomcat instead of giving it an executor service that does 200, pooled threads, or I think it's like a capped cached thread pool, or it goes up to 200. It doesn't just spawn up 200 immediately. But the default max is 200. Instead of giving it that type of an executor service, it gives it that one, whatever that big long name was. It was new thread, virtual thread per task executor. It gives it one of those. That's the essence of what it's doing. But you're right. If I have code of my own that's using normal threads, like if I'm doing new thread and spinning off things, or if I'm doing a regular old executor service in other places, I'll have to do that on my own. I'll have to fix those, upgrade those. Most people are using executor service for spawning things these days in a lot of places. So that should be a pretty easy upgrade. Good question. What else? All right.
So I'm interested in the stack frame copying business. Wouldn't copying stack frame to each virtual thread explode the garbage collection routes size?
So the question is, wouldn't copying all the stack frames, so we have virtual frames, every virtual thread, every virtual thread is going to have the same kind of setup as a regular thread. It's going to have the program counter and the stacks and the local variables and all of those things, just like a normal thread does. So the question was, is that not going to mess up our garbage collection routes? They struggled with this, right? So this was a big problem because you can't, as it scans, the garbage collector does a stop the world analysis. When it does, it goes through and scans the routes for what can I garbage collect? What's out there that what did the guy said they call them oops. I think it's object whatever, something that they can address, but they called them oops. Thank you. When it scans for those, it does a stop the world type of approach. Well, if you have 200 threads, not that big a deal. You know, 1 million, that could be a really big deal. So they don't do that. They don't actually become garbage collection routes, GC routes. The platform threads still are. What they do is they unmount. Got a whiteboard over there. They unmount, so they'll have like the stack frames. I'm going to take the stack growing down. So the stack as the carrier thread gets to the point where it's processing each one of the continuations. You can think of that as that's just going to stay. That's just how I got to the point where I can do continuations. Now, once the continuation pops on there, its stack grows and it comes to a point and then it yields. Well, wherever it yields, at the first time this happens, what they do is they take this off and it goes over in the heap. But it's still addressable by other means. There's a virtual thread unparker or something like that, something along those lines. That's going to be the GC route that can get to those things, and it's accessible, so it can still GC them if it needs to. When you reactivate or thaw one of those continuations, sorry, it was really interesting, and I know I can give you the gist of it. There's a lot more detail to it, but the gist of it was they didn't pull all of the stack frames over. They inserted a stack frame here that was basically like, okay, when you get to me, just ask me what to do. So they take the top 2 stack frames off the bottom over here when you reactivate this continuation. So the first thing that happened, okay, it pops off the stack and goes up, and now you got your route again. And then it might add more stack frames. But if it ever does drop back to here, that stack frame knows, okay, now I have to go reload. Anything that was interleaving in between, they lazily go get those things and bring them in only when necessary. And that turned out to be a huge performance increase for them. Does that help? It was pretty cool. I was like, wow, like I'm really impressed that there are people that think this deeply about these things.
In there, little stack frames on the heap. I've still got
Yes. Yeah, if you get into really deep virtual threads and they have a very deep stack, yes, you can start to overload the heap with a lot of information. But typically, virtual threads are not terribly deep. If you're calling into some framework code, like us Java people like our frameworks, and that stack's going to start to go a little crazy on you. But if it's straightforward stuff where you're predominantly controlling it, it's not going to get terribly gnarly on you, and it'll stay relatively shallow compared to from the root. How did I get here? Those are usually going to be very deep, but the processing from then, it's usually fairly shallow. Yes, sir.
Automatically with those virtual threads because they're resources.
The question is, my application, and I'm repeating it because there's people online, so not that I don't think you guys can hear him. The question is, if my application is using completable futures now, currently it's structured in that way, would you recommend just automatically switching them over? And I would say, I guess it depends on what you're using them for. If you're using them for the situation where you're kind of doing that scatter gather thing, I might not. But if you're doing a lot of chaining, you're using it to avoid blocking, and you're kind of leveraging the non-blocking style kind of all the way down that stack, yeah, I would probably look at figuring out. Now, if you've already bitten the bullet and it performs well, that's fine. The idea is I simplify my life, right? I get to write much more straightforward code, easier to maintain code. Well, I mean, I don't know who's paying the bills for the code you're writing, but if they're okay with refactoring, which I think is probably wise over time to clean those things up if you can, but it would just be a trade-off of what makes sense to the business, I guess. Just like any other tech debt, right?
calls, scatter, gathers, bottleneck. That regular virtual threads, that should be able to scale higher. Right? That might happen.
Yeah, so and I'm gonna try to paraphrase. The question is, if my completable futures, if it really is used in that kind of scatter gather sense where I'm going off and retrieving information out of a database, much queries at one time. I guess it depends on your database, right? So if it's a database that, you know, that you're probably gonna run into like database connection pooling issues anyway. You know what I mean? Like that goes back to that, like when we use thread pools, that kind of throttled us. Well, when we have database connection pools, that throttles us too. So you could be running into that issue. So you'd have to balance that as well. Any other questions? I had a couple little pieces of code. Are you guys still good to hang out for a little bit?
Yeah.
Cool. Okay.
I think I'm good.
Let me see if I can get this loaded. Let me stop mirroring, I think is the key I found. Okay. So I had one that was kind of interesting. So I did a dining philosophers exam. There's a lot of print stuff in here, and this is really about like getting different parameters from system properties and stuff. But everybody familiar with dining philosophers? And any people who could study computer science in the last 20 years probably know it better than I do. I studied it a long time ago. The idea of the dining philosophers, it's a resource, scarce resource exercise, basically. So you have a bunch of philosophers sitting around a table, and there's one fork in between each one of them, right? So you have just n forks and philosophers. Philosopher is going to think for a while, and then when he's getting ready to eat, he's eating like, let's say, spaghetti or something. He needs 2 forks in order to eat it. He's going to think for a little bit. He's going to look and see if the fork's available. He's going to pick it up, left fork, and then he's going to think for a little bit longer, and then he's going to pick up the right fork. When he has both forks in his hands, he or she, there can be female philosophers, I apologize, he's able to eat. He's going to eat for a little while, and then when he's finished, he's going to put down the forks, and he's going to go back to thinking. So that's the idea. And it's how do you manage that with just n number of forks and n number of philosophers? If each philosopher needs 2 forks at any given time, how am I going to manage those resources? So it's an exercise that people have done for many, many years, and it's an example. Well, I wrote one using virtual threads, and you can run it. Let's see, the default is like 5 philosophers and 5 bytes. They're going to take 5 bytes. So it's 5 times trying to pick up the forks, right? And the eat time is only like 50 milliseconds by default, right? So I'm just going to take a very, very short amount of time. So if we run that, I watch it blow up on me. Oh, I changed the parameters. So you can change this too. It took a little while. So let's run 0.0402 seconds, right? So they took 5 bytes and let me turn on the logging so you can see it actually does spit out log statements. It starts to get a little unwieldy when it's a lot of philosophers, right? They get very, very chatty. But you can see picking up left fork, putting up, all of the things. It's telling you what it's doing. I'm just getting ready to pick up the left fork, pick up the right fork. I'm going to eat, put them down, blah, 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 all these fun things. You can see this is, as we said, this is a fork join pool, right? You can see that the way they name the threads can tell you that they're virtual threads. Number 1, you see over here, this is a virtual thread. This is telling you what the carrier thread was over here. So we see we've got a bunch of different carrier threads. Can you guys see that? Is that text big enough? Sorry, sometimes it's not. Okay. 8, 9, 2, 1, right? So my MacBook has 10 cores. By default, the setting is when the JVM spins up that fork join pool, the parallelism, how many threads that it's going to take up by default is 10. Just by default, it uses 1 for every core of your CPU. The maximum threads that it can make available if it needs to like spin up another one in order to accommodate for something else is 256. That's the max threads, something like that. I've got the parameter here somewhere. So you can adjust that with a system property. So we can change that. So right here, you see it's using multiple threads, but we can do -d JDK virtual thread scheduler dot max pool size equals 1. So we can do that. So we're doing, if you notice, the name of the worker thread doesn't change. It's just worker 1. So we use kind of back to that old green threads, right? So M virtual threads to 1 operating system thread, that M to 1. Not very impressive with 1, or 5 philosophers, right? But we can run this, and I can do this on the command line, probably easier than doing it this way, but I can change the number of philosophers to, 5,000. Still 1 thread. Oh, probably should shut those things up because they're still less than a second, even though I left all the log statements in. And this little log trick is something I made up to be able to shut those things up quickly without doing find and replace. So it's not a built-in feature of SLF4J or anything, but it's just basically to shut them up. 0.6 seconds for 5,000 philosophers, right? So you can tinker around with this stuff. You can also bytes equals 10 bytes. Bytes equals 10 bytes. How many bytes each one of the philosophers is going to take before they're done. You can do I think it's just called eat time. We'll make it longer, 500 milliseconds. That's going to slow things down with 1 thread, right? Because they're pausing, but still 1.2. Again, only 1 thread. I'm doing 10 bytes now, twice as many bytes per philosopher. So they're going to do pick up the fork, do that 10 times instead of 5. But this is all, I'm spinning up 1 thread per philosopher here. That's how this is. Each philosopher is a runnable, and I'm spawning them. And this little spawner thing is just something I did to make it easier to read my demos. So there's a little interesting trick. Has anybody ever implemented dining philosophers? It's probably been a while if anybody has. So there was an interesting trick, the way that one of to avoid deadlock, because you can imagine if everybody grabs the left fork first, and we're all like, I got my left fork. We're 5 philosophers, 5 forks. We all have 1 fork in our hand, and we all have the left fork, and we're going to be waiting for that right one to go down. But all of them are going to be waiting for the right one to go down. Nobody's going to give up. So what they do is you make one of them a left-handed philosopher, or basically the opposite-handed. So 4 of them are going to grab the left one, but the 5th one's going to grab the right one. So I did it with max min, the index of the fork, whatever. So that's why that mumbo jumbo's in there. But that's how you have to do that. So you can see each one of those philosophers is spinning up a thread, and you can, again, I'll check this it's in GitHub. It's a public repo. You can play around with it, but you can jack this number up. Even on 1 thread, one carrier thread, you can, raise that number up 50,000 philosophers. It does start to slow down after a while. It has to, right? It's just kind of inherent. There's only so much processing it can do, but it does pretty well. This one takes a little bit. Let's look at the profiler a little bit just to see what it's doing. We'll let this thing play out. Maybe it's going to take too long. I won't. I think it's about 20-something seconds. Let's do. So let's profile this sucker. I'll let it run for a little bit. Any questions? Anybody? Any other? I wanted to show some stuff about pinning, showing how you can get around that and show what it looks like when you see a pin thread. And then something about the cooperative scheduling question. I bet Venkat doesn't have a dining philosopher's example in his talk. He probably codes the virtual threads himself while he's doing it. Yeah.
That's true.
He's pretty awesome. I like Venkat a lot. You guys, I'm going to tell you, you guys are lucky to have Mary here. I called Venkat to come to Senjug. Oh, yeah. I could probably get to you around 2026 or something like that. She calls him, I'll be there in November. Maybe I'll have you call him for Sinjug. Cincinnati, it's
ask him.
just, we don't get any love.
I'll ask him.
So look at this. This is built into the idea, the profiler. So look at this one worker thread, and this is what you want to see, right? This thing's running, slamming and jamming, lots and lots of processing, not a lot of blocking. Whenever things are blocked, you see this red. I don't see a lot of red here. I'm moving. This virtual thread worker is actually really moving and processing things and doing what we want it to do. That's the idea. You really want those threads to be very, very, very busy. And again, there's only one. I did 50,000 virtual threads on this one carrier thread, but that kept that sucker busy. We can do it again with a couple of threads. Speeds it up a little bit. So you said he's coming here in November.
In October.
Oh, October.
Yeah,
right.
for go to Chicago. He'll be speaking there, then he'll.
So it won't
want
be
to
like
do-
freezing cold in October and I could come up
Yeah.
here and see
Yeah,
VinCat.
you should come.
Okay, good.
Yeah, it should not be too cold
I would hope
then.
not.
Yeah. So.
It's not on Halloween, is it? Because I gotta go
Um,
get some candy.
Oh, yeah, that's true. It's like a week before Halloween. Yeah,
All right.
22nd, something. So, yeah.
So yeah, so now I have my two worker threads and they're both kind of keeping busy here until it's, finished. And then it goes into kind of this blocking because it's waiting for something to show up on the view. There's no continuations. It's just sitting there waiting on something to do. So that's what you want to see. Lots and lots of green. This is the idea. This is the exact thing you want to see when you're running virtual threads. Okay. Same thing with, I had this pinning. So there's pinning. So here's the property. Can you guys read that? So it's JDK trace pinned threads equals full. There's varying levels of detail you can get. But when you have it, when something does get pinned, you can tell it to print out information about that. So if I'm going to run, I have two different ways of doing this code. If I'm going to run this with a monitor, which is, does everybody know what a monitor is in Java? So that's when it's kind of that built-in inherent piece of it. Every object can act as a monitor in Java. Whenever you do the synchronized keyword on a method in Java, it actually really translates to synchronize parenthesis me, this, and you're synchronizing on the monitor of the enclosing object. So every object in Java has that built-in kind of monitor facility. So this is what happens. When you pin a thread, you're going to see one of these things spit out. And it's going to say, this is why. It shows you the monitor. And if you click on this stack trace, if you go look at the stack trace and see where that goes, I have this little runnables helper class. It's saying, now it's not on the synchronized line, it's on the inner run line. It's saying, I was within a synchronized block and I was doing something that I normally should be able to tell you, go park me somewhere. I'm going to go do something else. It's telling you I can't. I'm not allowed to do that right now because I'm within a synchronized block, a monitor. So this kind of helps you pinpoint where do I have this trouble. So that's how, if you look in, there's a discussion thread about MySQL and virtual threads. They were able to find it using something like this. Turn that setting on, and I would probably do that in my lower environments. Just turn that on. Yes, sir. If the question is, if a virtual thread is pinned, will it eventually complete? It'll just take longer. Yeah, it'll continue processing like it does. The problem is it's going to be, if it holds on to that monitor for too long, right? If it stays stuck within that monitor for too long. And this was I kind of forced it to, the way the example works. I have these little helper classes. So I do repeat 10 times and I wrapped a runnable with a monitor. And I put a delay of 1 second. So it's going to be holding on to that monitor for 10 seconds, right? So that's probably pretty gnarly. Or it's going to hold on to the monitor each time for a second. Sorry. There's even a threshold that it won't log. I think it's like 10 milliseconds. If it's anything longer than 10 milliseconds, it won't even log it. It's like, okay, it's close enough. But if you're for a prolonged period of time holding on to one of those, the monitor or doing a native call or whatever the case may be, putting the virtual thread in a position where it cannot unmount, it's going to let you know. But it'll still work. It's fine. It's just because it can't unmount, it will not let other people onto that thread. And we might be able to see it. Let me see if I can do both of these folks. And watch. I haven't even tried this, so this is live. Take that, Venkat. Just kidding. Did it not do it? Oh, don't comment both out. Uncomment both, duh. There he goes, talking on crap. Take that, Venkat, right? See what it looks like. Where's everybody else? Where's it running? That's not a lot going on. There's not a lot going on anyway, so it's not going to light it up. It's just kind of hard to see these little bitty green lines, but they're sprinkled in here. Yeah. There are other threads going on, but it's one stays on one. I think that's what we would see. Let's see. So you can see if you just look in the logs, monitor, if I highlight all the monitor, 2, 2, 2, 2, 2, he's stuck. He's stuck on 2, whereas the one used in reentrant lock, 8, 6, 1, right? He's able to bounce around to the other threads, but that one guy's going to be stuck. He's not going to give up that thread, that carrier thread to anybody else. So that's the idea. You're limiting. And if you can imagine in a server process, if you have, a bunch of those concurrent requests happening that happen to tie up one of those carrier threads, now you're really in trouble, right? Now, it is able to spin up new ones, right? It's what it did to handle the other things. But there's a maximum to that, 256. All right. And then that was pinning. And then what did I say the other one was I wanted to do? Oh, cooperative scheduling. Let's modify the JVM. I don't like that that's not visible by default. Oops, not JDM, JDK dot virtual thread scheduler dot max pool size equals 1. So this is kind of a really nasty way of showing this thing. So what's happening is I have a cooperative scheduling this little method down here that's just called sleepy. It says I'm going to go to sleep for 1 second and I finish sleeping after 1 second, right? It's just going to log back and forth, back and forth, back and forth, right? But then I have this really nasty thing, and this is serial, meaning do this over and over again forever, do a no op. And this, well, serial means do this and then this. There's a series of runnables. The first one was just to get a log statement pretty easily, kind of using this functional style. And then the last one is forever no op. So it's effectively, while true, empty block, nothing, just blah, 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 just spin, right? So if this were preemptive scheduling, doesn't matter if that thing's in a tight loop like that. The parent's going to come in, no, Billy, give that monkey to Susie, right? And it's going to force them to do that if it was preemptive. Now, I forced it to go to one thread because, if it ties up one thread, it's okay with that tight loop. The other ones are going to keep processing, but here I forced it to only have one thread. So one of them started and said, I'm going to go to sleep for a second. I'm going to go to sleep for a second. The one said, I'm getting ready to go in an infinite loop, and nothing happens after that. If it were preemptive, you couldn't do that. But because it has to, that while loop never touches a blocking operation at all. It never yields back to the to the scheduler and say, I'm okay, I can go off out of the way and make room for my friends. Nope. It never does it. It never encounters a blocking operation. So it's kind of preemptive because I really don't have to think about it, but it can mess it up and I can cause it to not do it anymore. I can change the threads and it'll run and the other ones will work. Just get rid of this and run it. See, like I went into Infinite Loop, these other guys went on their merry way using other threads, but that guy was being a hog and tied up that thread and never gave it up. And that's a forever, so I'll have to stop it. And this was a fun, I just created little classes for me to play around with stuff. There's, you know, little examples of those structured concurrency stuff that you can actually run and play around with. And as I said, you know, there's little helper classes in here for runnables and loggers and different stuff. The Olympics, I used an Olympics example. So there were tickets resource. So this is the thing where this is how I did my performance test. So this is the purchase tickets thing, and it's just making up something like, presumably folks would go through a background check when they're buying tickets for the Olympics, I would guess. And I try to do some timely example of, you know, so you're verifying the background of people to make sure they're okay. They're not on the Interpol watch list or something. You don't want them at the Olympics, right? Especially not where there are javelins around and whatnot. So that verify has a 500 millisecond. The Interpol verifier has a 500 millisecond delay in it. And then the Gatling test is an actual test. So let's see, we can run this sucker. What is it? So this is just a Spring Boot app. So then Gatling is, they call them simulations, right? So this is start with 100 users per second, you're ramping them from 100 to 1000 during, and this is the number of seconds, 300 seconds, 5 minutes. So that's kind of how you use that. That's their DSL. And you set up scenarios. What are you going to do? What do the requests look like? What should the responses look like? That sort of stuff. Very similar. You've probably, you know, done web testing stuff before. It's very familiar type of thing, but you can run that with Maven plugins, sorry. Gatling test. And we can sit here for 5 minutes if you want, but it does spit out. I don't know where we're at on virtual threads or not. Virtual threads are off. So over 5 minutes, it'll start to not be happy anymore. Not as happy at least. But that's if you want to run that. So you can just run your Spring Boot app locally if you'd like. Fire up Gatling. Again, I'll make the GitHub repo. You can find it on GitHub and I'll share it with you. Any questions? Comments? Anybody gonna go tinker with virtual threads? Anybody like, I'm just here for the pizza? That was me. I drove all the way to Chicago for that pizza. All right. We don't have Giordano's in Cincinnati. That was good. All right.
Yeah,
Well,
cool.
that's all I have then. Thank you all.
Thank you.
Unless you want to wait for 5 minutes.